I have a question for you, but before that, you should know that how does a knight moves on a chessboard? So first of all, a knight chooses any of the direction among up, down, left and right and take two steps in that direction, and after that it takes a 90-degree turn in any of the direction and take one step. For example, it can go two steps up or down, then take a 90-degree turn in any of the direction to move one step, or it can go two steps left or right and then take a 90-degree turn to go up or down one step. For example, it can move like this, or like this in the shape of L, or like this, or like this, or like this. Now let's move to the question. In how many ways two identical knights can be placed on a board of n cross n such that they are attacking each other, assuming that identical knights are allowed to attack on each other? For example, on this board here these two knights are attacking on each other because it can go two steps like this and then one like this to attack that knight. And in similar way, these two knights are attacking on each other, and we have to count such number of possibilities. After this, we will also discuss the same question for other pieces of chess like rook, bishop, queen and king, including knight. So here is the solution. Let us first observe that when these two knights are attacking each other, they are actually on the end of the diagonals of a rectangle, and dimension of that rectangle is 2 times 3, right? And if we choose any rectangle of dimension 2 cross 3, we can see that there are two possibilities in which knights can be placed in such a way. Okay, so what we have to do now, we now have to count the number of rectangles of dimension 2 cross 3, and then we will multiply it by 2. Why? Because there are two possibilities in each rectangle of dimension 2 cross 3 to find the total number of ways in which this condition can be satisfied of attacking each other. Okay. So let us see what we can do to count the number of rectangles of dimension 2 cross 3. The first thing is that we need a length, and another thing is that we need a width. So first of all, we have to choose 3 adjacent rows for the columns for the length, and 2 adjacent rows for the width, and on the intersection of these rows and columns we will find a rectangle of dimension 2 cross 3, right? Okay, now if we number these rows like 1 2 3 and so on up to n minus 2 n minus 1 and n, and we see that the possibility for length is 1 2 3 or 2 3 4 or 3 4 5 and so on up to n minus 2 n minus 1 n. Then if we count the possibilities of length, then we have 1 2 3 4 and so on up to n minus 2, right? So number of possibilities for length is n minus 2. In a similar way, if we number these rows or for the width, then like 1 2 3 up to n minus 1 and n, and start choosing, then we can have 1 2 2 3 3 4 and so on up to n minus 1 n, means 1 2 3 and so on up to n minus 1 means n minus 1 possibilities, right? Moreover, we can take length horizontally and width vertically, or width horizontally and length vertically, right? Means in total we have n minus 2 times n minus 1 horizontal rectangles and same number of vertical rectangles, so we have to multiply it by 2. So here are the total number of rectangles of dimension 2 cross 3, right? And now to find the total number of ways in which two identical knights can be placed on the board of n cross 1 n such that they are attacking each other is equals to these number of rectangles times 2 means 4 times n minus 1 times n minus 2. So this is our solution. For example, if we take n equals to 3 means a chessboard of dimension 3 cross 3, then there are 8 possibilities such that knights are attacking on each other. Here these 8 possibilities are shown on the screen. Now let's move to our next piece, bishop. And before that, you should know that how does a bishop moves on a chessboard, right? So what bishops do, it just chooses one of the diagonal directions and then move any desired number of steps in that direction. So it can go like this, or in this direction, or in this direction. Okay, so for example, it can move up to here, or to here, or from here to here, right? Okay, now let us make a similar kind of observation as we had made in the case of knights, that when two bishops are attacking on each other, they are on the ends of the diagonals of a square. So if we choose a square from that chessboard, then each square will have two possibilities because it has two diagonals such that these two bishops are attacking on each other. Okay, like the two possibilities of the square of this dimension 3 and two possibilities of the square or dimension 4, right? Okay, so now what we have to do, we have to count the number of squares, but there is a condition that side length should be more than 1, because if there is only one square, then obviously two bishops cannot be placed on that. So we don't have to count this square of side length 1, right? Okay, so let's start counting. If our board is of dimension 1 cross 1, then there are 0 squares of dimension more than 1, right? Now in this square or chessboard of 2 cross 2, we have only one square of dimension more than 1. Okay, now here in this chessboard of dimension 3, we have this 1, 2, 3, 4 squares of dimension 2 cross 2, and this one larger square of dimension 3 cross 3, right? So total number of squares is 1 plus 2 square. If we have a square of dimension 4, then how many 2 cross 2 squares we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of dimension 2 cross 2 plus 1, 2, 3, 4. 4 of dimension 2 cross 3 and 1 of dimension 4 cross 4, right? Okay, and now if we see this n, means if we take a chessboard of n and keep following this pattern, then we will have to add up to n minus 1 square to count the total number of squares of dimension more than 1. So by formula it is equals to n minus 1 times n times 2n minus 1 divided by 6. Okay, I have directly used the formula. Now on every square there are two possibilities, so what we will do, we will multiply these number of squares by 2. So this is the possible number of ways for bishop. Okay, so let us again see it for a chessboard of dimension 3. We get value 10, and here are the 5 possibilities, and here are the next 5 possibilities, means total 10 possibilities in which bishops can attack on each other. So this was our solution. Now let's move to our next piece, Rook. And here also, first of all, we will see that how a Rook moves on a chessboard. So what Rook do? Rook just chooses one of the directions among up, down, left and right and move any desired number of steps in that direction. For example, it can move like this, or it can go in the right, or it can go in the left, and it can again come back in the right, or it can go up, and so on. Okay. Now let us count that in how many ways two rooks can attack each other. So if we have a chessboard of n cross n, then here are n squared blocks on which a rook can be placed. Now suppose the rook which we have placed on the chessboard has a name capital A. Okay. Now we can see clearly that this rook is making an attack on n minus 1 horizontal, a vertical, and on n minus 1 horizontal blocks, right? Yes. Okay. Now if we have to place another rook B on which this rook A is attacking, so how many possibilities we have? We have 2 times of n minus 1 blocks on which this block B can be placed, right? Great. Now moreover, if its name is not A, it is B, and its name is not B, it is A, then this possibility is also counted what we have just calculated, right? Means in our approach, this AB and BA both are counted. Why? Because since we have taken these n square possibilities, means this can be the place where A can be placed, and after that in these two n minus 1 there is a place where this is the place where B can be placed, right? So we have counted AB and BA both in this, but if A equals to B, so we will count both of these possibilities as only one. Means what we get here, we get only n square times 2 times n minus 1 divided by 2, which is equals to n square times n minus 1. So for rook, these are the number of ways in which two rooks can be placed on a board of n cross n such that they are attacking on each other. Okay. For example, if we take n equals to 3, then we get number of ways equals to 18. So here are the 6 ways, here are the next 6 ways, and here are the next 6 ways in which two rooks can attack on each other. Okay. Now let's move to our next piece, queen. Again, let us learn how does a queen moves on a chessboard. So actually, queen is the most powerful piece on the chessboard, not most important, most powerful piece on the chessboard, and its moves are just the combination of rook and bishop. So it just chooses any direction, horizontal or vertical, and it moves any steps in that direction. Okay. For example, a queen can move like this, means one step diagonally, or it can move like this, or it can move any number of ways, any number of steps horizontally or vertically, right? Okay. So now let us count the total number of ways in which two queens can attack on each other. So what we will finally get the total number of ways in which two rooks can attack on each other, and plus total number of ways in which two bishops can attack on each other, because its moves are just the combination of the moves of rooks and bishop, right? So on adding the number of ways of both of these, we finally get n times n minus 1 times 5n minus 1 divided by 3. Okay, and here I am not taking example because the number will become so large to count it on the screen. You can do it yourself. Okay, now let's move to our next piece, king, and I am leaving this piece for you, so do yourself. Okay, and tell us in comments. And this was all for today. So, and don't forget to like and share our video. For more such videos, subscribe to our channel Brain Exploders. Thanks for watching.